Students, let us go through some portion in which we are going to study about resistance and resistivity. Let us assume that this is a copper wire of some length L1 and the area of this cross section is A1. Now the copper wire remains the same because we are using copper wire. I am just increasing the length of the copper wire from L1 to L2, and area is also changed from A1 to A2. So I can say that when I am changing length and area, the resistance of this copper wire will change because I changed length and area. But resistivity of copper wire doesn't change with length and area. So by changing length and area, the resistivity will remain same. It will not change. So as per the information given in textbook, the values of resistivity depends on different materials. This is resistivity of insulators, this is resistivity of semiconductors, resistivity of alloys and conductors. As you can see the relation between all of them, insulator is having the highest resistivity, then comes the semiconducting material, then comes the alloys, and then comes the conductor. If you compare alloys and conductors, alloys are having more resistivity than conductors. But combinedly, they are having resistivity in the range of 10 to the power minus 8 to 10 to the power minus 6 ohm into meter. And by chance it is insulators which are having more resistivity, that is 10 to the power 12 to 10 to the power 17 ohm into meter. Students, let us know about combinations of resistors. That means how as many as resistors you can connect in different types of connections. Especially there are two types of connections, series and parallel connections. Let us start with series connections. We have considered three resistors here, R1, R2 and R3. If we want to connect them between two terminals in series connection, let us say there are two ends of resistor. The second end of the resistor is connected with one of the end of a resistor, and again second end's resistor is connected with the third end. This is how you connect the three resistors in series. Now as you know that these resistors are connected in series connection between the points A and B. So I can consider them in series, but one of the idea to find that if they are in series connection is if current I is passing through this combination, then current is having only single path to travel. That means same current will pass through each and every resistors. Now second part is if you apply potential difference by combination of cells or a battery, then the voltage is distributed between individual resistors. If you apply V volt potential difference, the potential difference between the individual resistors will be equal to the addition of this. Let me show you how. Let us say if we are applying V volt by this combination of cells, then potential difference across each resistors will be V1, V2, V3, and this potential difference applied will be equal to the sum of individual potential difference across the resistors. Let us find out the equation for equivalent resistance where resistors are connected in series. So as per Ohm's law, if V is the potential difference applied across the resistors, then V is equal to I into R. The current passing through the circuit is I, and resistance of combination of 3 in series is Rs, which is known as equivalent resistors, which is equal to V1. Let us say that V is equal to I into R. If V is equal to I into R, then V1 is the potential difference across resistor R1, but current remains same, so it is IR1, because there is only one path for the current, so current is not getting distributed. V2 is across R2, which is equal to IR2, and V3 is equal across R3, that is IR3. Now substituting this value in above equation, we get IRS in this, which is equal to V1. V1 means IR1, V2 means plus IR2, V3 means plus IR3. And that's why taking I as common from this terms, I is equal to R1 plus R2 plus R3. So I can cancel out I from both the sides, or divide I on both the sides, and get one equation for series combination, which is equal to R1 plus R2 plus R3. So this is the equation for series combination. So this is the equation for n number of resistors which are connected in series. Let us take one example. If 3 resistors are connected in series, one of 10 ohm, the other is of 20 ohm, and the third one is of 30 ohm, then first answer will be, it is 10 plus 20 plus 30, that is equal to 60 ohm. Now you will notice that if 30 is the largest resistor which we connected in series, our equivalent resistance will be greater than the largest resistance connected in series. So let us say if we are connecting identical resistors in series, it is very simple, 2 plus 2 plus 2, that is 6 ohm. Or simply, if there are many resistors, then we can connect it as this equation. Rs will be equal to N multiplied by R. R is the value of resistors. Let us say same resistors. There are same resistors and its value is 2 ohm. Fine. How many resistors are there? 3. So when I multiply it by the number 3, that is N, I get the series resistance 3 to the 6 ohm for identical. So this is a simple derivation as well as use of series connection. Thank you.